Okay, good morning, everyone. So now we can discuss the remaining assertion reasoning questions, okay, from chapter 10, haloalkenes and haloarenes. Till which question we had discussed? Can you tell me?
61.
Okay, 61. Next one is 62. Okay. '61. Then question number 62, right? Here the assertion in monohaloarenes, further electrophilic substitution occurs at ortho and para positions. Reason, halogen atom is a ring deactivator. In monohaloarenes, further electrophilic substitution occurs at ortho and para positions. Reason, halogen atom is a ring deactivator. What about the assertion? Is it correct or not? Assertion. In which positions this electrophilic substitution reaction takes place? Ortho, para, or meta? Rijas, which positions?
Ortho and para.
Okay, ortho and para. So this assertion is right, isn't it? In monohaloarenes, further electrophilic substitution occurs at ortho and para position. Then what about the reason? Halogen atom is a ring deactivator. Yes, can you tell me, is this the reason? Why this electrophilic substitution reaction occurs at ortho and para position? Anyone? Naureen, can you tell me?
Because the halogen is ortho-para directing.
Halogen atom is ortho para directing, or otherwise electron density is more at ortho and para position, right? Due to these two reasons, the monohaloarenes further electrophilic substitution reaction occurs at ortho and para position. This one is also a right statement. Halogen atom is a ring deactivator, but this is not the actual reason for the assertion. Okay, so here answer is B. B. So you can write the reason. Halogen atom increases electron density at ortho and para positions. Then question number 63. Hydrolysis of minus 2 bromoctane Okay, that is LEVO. Okay, 2-bromo-octane proceeds with inversion of configuration. Reason: this reaction proceeds through the formation of a carbocation. Assertion: hydrolysis of 2-bromo-octane proceeds with inversion of configuration. And the reason: this reaction proceeds through the formation of a carbocation. What about this assertion and reason?
Assertion is true.
Assertion is true. Yes, hydrolysis of 2-bromo-octane, it will proceed with inversion of configuration. Okay, then what about reason? Is this the correct one? In the inversion of configuration, which mechanism? Inversion of configuration.
SN2 mechanism.
SN?
2.
SN2 mechanism, right? Okay, SN2 mechanism. So this reaction proceeds through the formation of a carbocation. Is it correct? In SN2 mechanism?
False.
False. Okay, it's false. So which option? A, B, C, or D?
C.
Which one?
C.
Yeah, C. Here the hydrolysis of 2-bromo-octane, it proceeds with inversion of configuration. So the mechanism is SN2 mechanism. In SN2 mechanism, there is only single step. The attacking nucleophile and the leaving group, it will take place, its act on same step itself. Only one step there. Okay. So this reaction does not proceed through the formation of a carbocation. You can write the actual reason. Reaction proceeds through SN2 mechanism. SN2 mechanism in which OH minus ion attacks at 180° to the halogen atom. Of 2-bromo-octane, which leads to inversion of configuration. Do you remember the mechanism of this SN2? And an incoming nucleophile, when it approaches near to the sender, what happens? The all other groups, it will be move apart from the incoming nucleophile, right? So the inversion of configuration takes place. Then 64. Have you completed?
Which one?
Yes. 1 minute. So have you completed question number 63? You can copy the reason also. Naurin, Sania, Emmanuel, Srihari, Malavika, Aryan, Michael, all of you switch on your videos. Okay. Then Anna, can you read question number 64?
Yes, ma'am.
Hmm.
Assertion nitration of chlorobenzene leads to the formation of M nitrochlorobenzene.
What is M? M?
Meta.
Yeah, it's meta. Okay.
Reason NO2 group is meta directing group.
Yeah, NO2 group is a meta directing group. What about this assertion and reason? Anna, can you tell me about the assertion? Nitration of chlorobenzene leads to the formation of meta nitrochlorobenzene. Is this correct?
Yes.
Yes.
No, ma'am. Nitration.
Nitration leads to which all products?
Ortho and para.
Very good. Ortho and para. So this assertion is wrong. Then what about the reason? NO2 group is meta directing. This is correct or not? NO2 group is meta directing. Actually, we didn't learn about the nature of this NO2 group, right? Take your textbook, children, page number 340. You can see the nitration reaction, isn't it? Page number 314, electrophilic substitution reaction. The second one is nitration reaction. Here the products are obtained on ortho position and para position. Okay, ortho position and para position. The halogen atom, it has minus I effect. What is minus I effect? It will withdraw electrons from that ring. But this NO2 group, that is a meta directing group. So you can note this point or in the textbook. Okay, NO2 group, that is meta directing group. Meta directing group. Clear? NO2 group is meta directing group in the case of electrophilic substitution reaction. But we have learned about nucleophilic substitution reaction, the presence of electron withdrawing group NO2 at ortho and para position. In the case of nucleophilic reaction, it is ortho and para directing, but here it is meta directing group. Clear? Any doubt? So what about this question number 64? Which option? A, B, C or D?
D.
Which one?
D.
D. Okay. D. What is D?
Reason
Assertion is,
correct. Assertion.
yeah, reason is correct. Assertion is incorrect. Okay. So shall I move to next question, children? I already sent this case study in your class group. Okay. You can read it as yourself. You can just answer the questions. Okay. The following questions are multiple choice questions. Choose the most appropriate answer. Clear? So who will read? Michael, can you read the first question? SN1 mechanism here.
SN1 mechanical mechanism is favored in which of the following solvents? A, benzene, B, carbon tetrachloride, C, acetic acid, and D, carbon disulfide.
Okay. SN1 mechanism is favored in which of the following solvents? Option A, benzene. Option B, carbon tetrachloride. Option C, acetic acid. Option D, carbon disulfide. SN1 mechanism is favored in which of the following solvents? We have learned about some type of solvents that helps or favoring SN1 mechanism. Do you remember the name of such solvents?
Polar.
Very good. Polar protic solvents. So among these four options, which one is such a protic solvent? What is protic solvent?
Acid.
Very good. Acetic acid. Option C. Protic solvent means they can able to donate H plus ions. Okay. Donate H plus ions. So the correct answer is option C, acetic acid. Acetic acid. Aditya, can you read the next question? Please switch on your videos, children.
Yes, ma'am.
Mm.
Nucleophilic substitution will be faster in case of
Options.
option A 1 chloro,
Mm.
2,2 dimethyl propane.
Mm.
Option B 1 iodo,
Mm.
2,2 dimethyl propane.
2,2-dimethyl propane.
2,2
Okay.
dimethyl propane.
Mm.
Then option C
Mm.
1 bromo, 2,2 dimethyl propane.
Okay.
Option D 1 fluoro,
Mm.
2,2 dimethyl propane.
Okay. So in which case the nucleophilic substitution reaction will be faster? Okay, here you can see the options. 1 chloro 2,2-dimethyl propane, 1 iodo 2,2-dimethyl propane, 1 bromo 2,2-dimethyl propane, 1 fluoro 2,2-dimethyl propane. Here the only difference in the type of halogen atom, right? And you know the reactivity of halogen atom in both type of mechanism. Then you can tell me which one is correct answer, A, B, C or D. Yes, which halogen is most reactive? Fluorine or chlorine or bromine or iodine? Which one?
Iodine.
Iodine. So which one is the answer?
B.
Yes, option B. 1 iodo 2,2-dimethyl propane. 1 iodo 2,2-dimethyl propane. Always the reactivity of this alkyl halides, it will increases with the increase in the position of halogen atom in a group. Okay, when we are moving from top to bottom in a group, in the case of halogens, their reactivity will be increases. It's in the order fluorine, chlorine, bromine, iodine. So iodine has the most reactivity towards nucleophilic substitution reaction. Okay, then you can skip this question, that is not in the syllabus. Then question number 4. Vidur, can you read the question? 4.
Polar solvents make the reaction faster as they
Hmm.
option A
Hmm.
destabilize transition state and decreases the activation energy.
Hmm.
Option B destabilize transition state and increases the activation energy.
Hmm.
C stabilize transition state and increases the activation energy.
Okay.
And D stabilize transition state and decreases the activation energy.
Okay. Polar solvents make the reaction faster as they destabilize transition state and decrease the activation energy, destabilize transition state and increase the activation energy, stabilize transition state and increase the activation energy, stabilize transition state and decrease the activation energy. Among these 4 options, which one is the correct answer?
Polar solvents mean.
Polar solvents means we have learned about this polar protic solvent means I will explain, just wait. If there is one electronegative element and electropositive element, there will be a chances for polar covalent bond. Okay, polar covalent bond. All of you please switch on your videos. Which are the electronegative elements? Usually halogens are electronegative elements, right? So when they are involved in chemical bond or covalent bond, they have a tendency to attract the shared pair of electrons towards themselves. Okay. So this hydrogen or the electropositive element, it will acquire or it will get a partial positive charge, and this electronegative element, it will acquire a partial negative charge. Okay. So this type of a charge acquiring, that is known as polar bond. Clear? Clear, Emmanuel? Is this clear for you? Okay. When an electropositive element and electronegative element, they are involved in chemical bonding, electronegative element have a tendency to attract the shared pair of electrons towards themselves. We know that in covalent bonding, sharing of electrons take place, right? Both atoms will share electrons. But this electronegative elements have a more tendency to attract the shared pair of electrons towards themselves. Okay, so they are receiving electrons. They are attracting electrons. So they will acquire a partial negative charge, and the electropositive element, it will get a partial positive charge. Clear? Such type of bonding is known as polar bond that exists
Okay.
in covalent bonding itself. Clear? Yes. So such polar protic solvents are, protic solvent means they will donate H plus ions along with this polar bond. Clear? So you can tell me among these four options, which one makes polar solvents react faster? Anyone? What is activation energy? We have learned it in chapter 4. Do you remember? In the chemical kinetics and the surface chemistry also. Some energy is needed to convert the reactants to products. Do you remember this graph? If this one is reactant and this one is the activation energy, it is converted to product. So this is the amount of energy required to convert this reactants to product. This one is the transition state. TS. Transition state. So among these four, which one is the correct answer? So if the activation energy is lesser, it will be easily converted to product. That's the clue for this question. Now you can tell me. Anyone? Gayatri, can you try?
D, ma'am.
Yes, very good. Stabilize the transition state and decrease the activation energy. If the activation energy is less, it can easily convert it to product. Okay? And it will stabilize the transition state. Clear, children? Yes.
Which part of the textbook can I find this?
Achut, yeah.
No, ma'am, is this there in the textbook?
Actually, this question from chapter 4, that's for your term 2, but it is connected to this polar solvents, right? That's why here it is asked. Okay. Yes. So you can write the reason. Yeah, Nandana.
Ma'am, what do you mean by stabilize the transition state?
Stabilizing transition state means this transition state is actually does not exist for a long time. Okay. It will exist for a very short time. Clear? So to make it stable for some time, stabilization is required. Clear? So this polar solvents can have a capacity to stabilize this transition state and it will reduces the activation energy.
So, ma'am, shouldn't it be A?
Once again, Nandana.
What is the difference between A and B? Like, how do you destabilize?
Destabilize means it will not help in the existence of that transition state. It will not create transition state. Actually, this in between this reactant and product, there is a stage known as transition state. Clear?
Yes, ma'am.
So sometimes the reactants should pass through this transition state to convert to product. If it is destabilized, it will not reach the product. The
Okay.
reaction will not be completed. That's it.
Okay. Thank you.
Okay. Yes. Then question number, yeah, fourth question, one more question there. So SN1 reaction will be fastest in the case of option A, 1-chloro-2-methyl propane, B, 1-iodo-2-methyl propane, C, 1-chlorobutane, D, 1-iodobutane. Here the reaction is SN1 reaction. SN1 reaction. So you can tell me. What is the order of SN1 mechanism in primary, secondary, and tertiary?
Tertiary greater than.
Yes, very good. Tertiary greater than, secondary greater than primary. Then what about the order of reactivity in halogens?
Iodine greater than.
Iodine greater than, bromine greater than, chlorine greater than, fluorine, right? Yes. So this is the order. Now you can tell me. Option A is 1-chloro-2-methyl propane. Option B is 1-iodo-2-methyl propane. C, 1-chlorobutane. D, 1-iodobutane. Which one? Question 2. Malaviga. Malaviga, you can tell me. Which one is the correct answer? Malaviga, are you there?
Yes, ma'am.
Yes. Can you tell me? Here tertiary group
Ma'am,
is
option D.
option.
D.
Very good. Option B. 1 iodo, 2 methyl propane. Okay. Because it comes under the secondary group, right? Secondary. Shall I move to next question?
Yes, ma'am.
This one also case study question. Okay. So we can read this paragraph as your own. I already sent it in the WhatsApp group. Okay. So first question, in a nucleophilic substitution reaction, the least reactive compound is option A, CH3, CH2Cl, option B, CH3 thrice CCl, option C, CH2 double bond CHCl, option D, CH2 double bond CH2Cl. Which one is the least reactive compound?
Ma'am,
Yes.
can you enlarge the size?
Yeah, sure.
Ma'am,
Yes, Achu.
should we look at the concentration of alkyl halide?
Once again, Achu.
No, ma'am, are we doing this based on the concentration of alkyl halide?
Concentration of alkyl halide. Means first question.
Yes, ma'am.
Not concentration. In this chapter, we are not discussing about concentration, right? That's depend upon the double bond position, then primary, secondary, or tertiary, like that.
Okay, ma'am.
Yes. Then can you tell me which one? Yes. Any idea? Children? Here this one is least reactive. The reason is that it belongs to the category vinyl halide. Vinyl halide, because this halogen, it is directly attached to the double bond. So this vinyl halides are least reactive. Vinyl halides are least reactive. Because of double bond character. Character in CX bond. Then look at the next question. Here this one is a tertiary halide, right? Tertiary alkyl halide. It is on treatment with a nucleophile gives the nucleophile substituted tertiary group, isn't it? This halide, it is replaced by one nucleophile. So in which condition the product yield will be maximum? in which condition the product yield will be maximum? A, CCl4 as a solvent, then BH and the halogenous chlorine, BH2 as a solvent and the halogenous chlorine, then C, CCl4 as a solvent, halogenous iodine, DH2O as a solvent and the halogenous iodine. Which case? In which condition the product yield will be maximum? Srihari, can you tell me? Srihari,
Option C.
option C. Why it's CCl4? Yes. We have learned that polar protic solvents make the reaction faster, right? Which one is the polar protic solvent among the CCl4 and H2O? H2O, right? Because it has able to donate H plus ions. H2O, then acetic acid, then alcohol. These all are polar protic solvents. Okay. So H2O as a solvent and the halogenous iodine. Option D is the correct answer. Clear?
Ma'am,
Yes.
what about chlorine?
Here the reactivity order, it is like this, right? Iodine, then bromine, chlorine, then fluorine. That's why X equal to I.
Okay.
Yes. Then question number 3. The reagent which can react with 2-bromopropane to give mainly a substitution product is option A, sodium sulfate, option B, sodium cyanide, option C, sodium chloride, option D, sodium ethoxide. Reagent which can react with 2-bromopropane to give mainly a substitution product. Among the sulfate, cyanide, chloride, ethoxide, which one acts as a nucleophile? Sulfate, cyanide, chloride, ethoxide. Which one? You're familiar with one nucleophile, right? That has a speciality also. Which one? It is ambident nucleophile.
Fine.
Cyanide, right? So option B, sodium cyanide. It will act as a nucleophile. The Cn minus, it will act as a nucleophile. So the reagent which can react with 2-bromopropane to give mainly a substitution product is sodium cyanide.
Ma'am,
Yes.
is this there in textbook?
Same reaction about 2-bromopropane.
Yeah, ma'am, and the explanation also.
It's not a direct question. Just wait. Let me check. Actually, it's not a direct question. We know that the cyanide, it will act as an ambident nucleophile, right? So it is the most possible reagent that can be reacted with 2-bromopropane for the substitution reaction. Okay, that's why it is sodium cyanide. Then next question. N-butane on monobromination gives 3 isomers. The product obtained when the major monobromo product is heated with alcoholic KOH will be N-butane on monobromination gives 3 isomers. The product obtained when the major monobromo product is heated with alcoholic KOH will be option A, but1-ene, option B, but2-ene, option C, 2-ethoxybutane, option D, butane-2-ol. Here the reagent is alcoholic KOH. So which type of reaction is this? Alcoholic KOH. Yes. N-butane on bromination. First reaction is this one, N-butane on bromination. Here bromo substituted butane will be obtained, right? Bromo substituted butane will be obtained. Again, this one is reacted with alcoholic KOH. So in which reaction we will use this alcoholic KOH? Substitution reaction, elimination reaction, or reaction with metal? Which one? Tell me.
Elimination.
Elimination reaction, right? Alcoholic KOH is the reagent that is used in elimination reaction. In elimination reaction, the haloalkanes are converted to alkenes, right? So here it is butane. So the product obtained is but2-e. So in the first reaction, N-butane on bromination, bromo substituted butane will be obtained. Bromobutane is obtained. Okay. And again, it will react with alcoholic KOH. Then elimination reaction take place. And this double bond will be formed between the two carbon atoms. And this bromine will be eliminated. Clear? Bromine and hydrogen will be eliminated. And the bond will be double bond. CH3, CH2, CH2, CH3. This is N-butane, right? On reaction with bromine, it will become CH3, CH2. There are 3 isomers. We can write any one. CH2, CH2, then CH2, Br. Okay, wait. CH2, then CH3. Here is bromine. So on reaction with alcoholic KOH, what happens? This bromine and 1 hydrogen will be eliminated. Then the product obtained is CH3, CH2, then CH3, CH, double bond, CH, CH3. CH3. Clear? This is the reaction. So the answer is but2-ene. Then one more question. First question. Okay. Reaction of tertiary butyl bromide with aqueous sodium hydroxide follows. SN1 mechanism, SN2 mechanism, any of the above, then E1 mechanism. Tertiary butyl bromide. So which mechanism? SN1 or SN2? Tell me. Tertiary SN? SN1 mechanism. Because in SN1 mechanism, tertiary is more stable or more reactive than secondary and primary. That's why. Okay, then you can practice the remaining questions from this chapter. There will be next set, that is assertion reasoning question. But now it's time, right? So you can practice as your own. Assertion reasoning questions will be there. and one more set of case study question. That's also assertion reasoning. If you have any doubt in any of this question, you can ask me. Okay. Bond cleavage in haloarine is difficult than haloalkane. Reason as phenyl carbocation is more stable than the remaining things. Okay, now it's time, children. So let me take your attendance. Just wait. Thank you, children, and see you in the next class. Bye.
Thank you, ma'am.
Thank you.